In this video, we will talk about comparative advantage and see an application of that in a simple two-country, two-good, one-resource case. So we are given that US workers in an hour can produce 100 shirts or 20 computers. And we're also told that in China, workers can either make 100 shirts or 10 computers. So we are given the output possible by each worker. 100 shirts, 100 shirts and 20 computers in the US, and 100 shirts and 10 computers in China. First, we are asked to plot the PPF for each country, and then we are asked to determine what the production will be if the workers were to split their time between the two goods. And then we have to determine the pattern of trade. In other words, we have to determine which country will export shirts, which country will import shirts, and then which country will export computers and import computers. And we've also been asked to figure out the price at which this trade can take place. So the first thing we need to do is to plot the PPF. And we can assume the case of one worker, or we can scale it up as we did to 500 workers or 100 workers. The analysis will be the same because the ratios are what matters and they do not change given how many workers you have. So let's begin by drawing US PPF. We're told that if American workers devote all their time, they can get 100 shirts. So the first point on the x-axis will be of shirts, and then if they devote all their time to computers, they can get 20 computers. So this will be the United States PPF. Similarly for China, if they devote all their time to shirts, they can get 100 shirts. If they devote all their time to computers, they can get 10 computers. So this will be the PPF for China. And if workers devote half their time to each good, so let's say we have one worker, in an hour they can produce 100 shirts in the US, so in half an hour they can produce 50 shirts. They can produce 20 computers in the US in an hour, so in half an hour they can produce 10 computers. So dividing their time equally would result in a country being in the middle of its PPF. So here we would have 50 and 10. Again, we can scale it up. If I had 1,000 workers, I would just multiply all of it by 1,000. If I assumed we have 100 workers, we would multiply all of it by 100. So we're just working with the simple case of one worker or 1 hour available. So this would be the production and consumption point in China, 5 and 50. And in the US, it would be 10 and 50. Now in part B, to determine which country has a comparative advantage, we can look at the opportunity cost. And again, notice, as we have said before, the opportunity cost is given by the slope of the PPF. Specifically, the slope of the PPF gives us the opportunity cost of whatever good we have on the x-axis, shirts in this case, in terms of the good on the y-axis given up. So I'm going to start by writing the opportunity cost of the way I've plotted. I have shirts on my x-axis. So opportunity cost of shirts in terms of computers given up is rise over 1, which is 20 over 100 or 1/5. Computers. Similarly, the opportunity cost, and this is for the US, the opportunity cost in China is again the rise over run of their slope of the PPF, which would be 10 over 100, which is 1/10 computer. So right off the bat, we can see that US has a higher opportunity cost of shirts. In other words, China has a lower opportunity cost of shirts. They give up less computers, they give up 0.1 computers, whereas US gives up 0.2 computers. So China will have a comparative advantage in the production of shirts. We can see the opposite is the case for computers. So to find out the opportunity cost of computers, the opportunity cost of computers in the US would be basically the reciprocal of this, which would be 5 shirts. Then the opportunity cost of computers in China would be the reciprocal of this, which would be 10 shirts. So here, these numbers tell us that the US has a lower opportunity cost of computers in terms of shirts given up 5, and China has a higher opportunity cost. So if you allow for trade, what this implies is that the US has a comparative advantage in the production of computers. And China, by default, conversely, has a comparative advantage in the production of shirts. Thus, if we allow for trade, we'll see that the US will export the good in which is a comparative advantage, which in our case is computers, and China will export the good in which they have a comparative advantage, and in that case that could be shirt. So in China, the cost of shirt is 0.1 computers. In the US, cost of one computer is 5 shirts. And these numbers are lower than the corresponding cost of these products in the other countries. So then the third question is, at what price can trade take place? And as we've seen before, as long as if you're focusing on the price of computers, it has to be between 5 shirts and 10 shirts. US producers will be willing to export computers as long as they can get more than 5 shirts. Chinese consumers will be willing to import computers as long as they can get it for less than 10 shirts. Conversely, Chinese exporters are willing to export shirts if they can get more than 0.1 computers, and US consumers are willing to import shirts as long as they can get it for less than 0.2 computers. So we can come up with any number in between, and that will allow us for trade to take place between these two countries. So let's say that the world price or the free trade price of computers, the free trade price for computers in the international markets is 8 shirts. This is acceptable to both countries for trade to take place. US can export shirts for more than what they get domestically, and Chinese consumers will import shirts because they can get it for less than what they can get domestically. Similarly, or we can just take the ratio of that, this implies that the free trade price for shirts is basically opposite or 1/8 of that, or 0.125 computers. And again, at this price, trade will take place for shirts as well, because US consumers can get shirts for cheaper than what they get domestically, and Chinese exporters of shirts can sell shirts for more than what they can make domestically. So if we stick with this price, then this will tell us what the consumption possibility frontiers will be for both countries. Again, we're working for the case of one worker. If you're working with 100 workers, we would have scaled it up. So given this, US will specialize in computers. So our production will be only of computers. We'll produce 20 computers. And if hypothetically we were to export all of them, then we could get 160 shirts in return. So this 160 is our consumption's possibility frontier. Similarly, China is going to be focusing only on shirts. So they will be producing 100 shirts. If they were to export all these shirts, and for each shirt they can get 0.125 computers, then by exporting 100 shirts they can get 12.5 computers. So this line, the green line, is China's trade or consumption is possibility frontier. And again, as we can see, these green lines were not possible without trade. Both countries were confined to their blue ppf, so they would have been able to consume only at this point. And now with trade, these countries can expand their consumption beyond their ppf. So we see that trade has made both countries better off by allowing them to go beyond their ppf. Hope this clarifies the idea of comparative advantage. This is a different way of looking at comparative advantage than the one we've typically done in class, where we have looked at um, productivities or units labor required for each unit of output. Here we're looking at how much can each worker make in an hour. But the idea of CA is still the same. You find the opportunity cost for each good. The country which has a lower opportunity cost for one good has a comparative advantage in that good. Then by default, the other country will have a comparative advantage in the other good because the opportunity cost of that good will be cheaper in that country than the first country.